A perfect celestial mirror floats 40 light-years away, crowded with 7 rocky worlds. Yet the stellar fire, meant to kindle life, likely destroyed their atmospheres billions of years ago. Does this distant architectural marvel preserve the genesis of an alien biosphere, or does it guard an ancient, airless graveyard? Humanity now turns its most sophisticated space telescope toward this tightly packed planetary alignment. 7 distinct worlds circle a dim parent star, mimicking the foundational profile of our own home. Astronomers cross an intellectual threshold. And what the data shows next changes the course of the investigation. We are no longer merely cataloging points of light in the boundless dark. Now they interrogate the very edges of cosmic habitability itself. Investigating the innermost frontier of this system requires measuring pure thermal signatures. In April 2026, researchers from the universities of Bern and Geneva completed a landmark 60-hour observation campaign. Their focus rested squarely on the 2 worlds closest to the central stellar furnace. The results quietly, unforgivingly overturn our initial optimism. Instruments measured the precise infrared emissions radiating from the sunward side of the innermost world. The data exposed a barren surface reaching 227 degrees Celsius. Published in 2026 in the journal Nature Astronomy. The measurement rules out any atmosphere thicker than a single bar of pressure on this scorched world. Such extreme temperature rules out any significant atmospheric shield, leaving behind a naked, lightless rock. The second planet reveals a similar desolation, preserving a surface as bare as our own moon. Its day side still radiates near 96 degrees Celsius, cooler than its neighbor, yet still far too hot to trap a breathable atmosphere. What stole 2 entire atmospheres so completely? Picture yourself holding a smooth stone directly over an open flame to understand this severe environment. If you pull the stone away, it radiates heat into the cold room, but it holds no moisture. The cosmic reality acts exactly like that heated stone, absorbing starlight and venting it back into the void. This absolute lack of gas loops back to an extraordinary mystery still threatening the outer worlds. If this cosmic architecture breaks your assumptions about how biospheres survive, what follows expands the horizon further. Turn on notifications and hit subscribe, because the next discovery goes even further into the void. Humanity now pushes its focus outward into the middle corridor of the system. Here lies the 4th world, a rocky sphere matching 90% of Earth's physical dimensions. This world orbits squarely inside the star's habitable zone, the exact distance where liquid water could persist on a rocky surface. 2 independent 2025 studies led by the James Webb Space Telescope DREAMS program analyzed this world. Data sweeps revealed subtle, shifting indicators of methane drifting through the light. If genuine, the signal could point toward a hazy, nitrogen-rich atmosphere, the tantalizing profile of a real-world exotitan 40 light-years from home. This fragment of information immediately sparked a profound debate within the global scientific community. Methane can act as a prominent biosignature, indicating active chemical processes on a planetary surface. A third cautious paper swiftly urged absolute restraint among researchers, creating a temporary deadlock. The authors argue that this riveting signal might not belong to the planet at all. Instead, molecular fluctuations inside the outer layer of the star itself could project a phantom signature. A dedicated new observing campaign is already queued to settle the question once and for all. This technical clash escalates the stakes, turning what we merely observed into an ongoing cosmic detective story. If the methane represents a stellar illusion, our best candidate for life remains a bare, sun-blasted stone. Every dynamic answer we harvest uncovers a more complex, unresolved question about the limits of our sight. Hope and static chill now hang suspended, waiting for the next signal. Isolating a planetary signal from the chaotic output of a red dwarf requires extreme observational precision. The parent star constantly pulses with turbulent magnetic currents, altering the starlight traversing the planetary rims. Stellar noise corrupts our only tool, transmission spectroscopy. The cosmos hides exactly what we most need to see. To bypass this barrier, astronomers have initiated 15 additional space telescope transits. The candidate world is paired against the confirmed airless innermost planet. By subtracting the known lifeless profile of the first rock, researchers isolate the true planetary signal. This process strips away the confusing stellar veil, and what waits underneath could confirm or collapse everything. This meticulous subtraction technique reshapes our entire understanding of modern exoplanetary research. If the method fails, our conclusions regarding alien atmospheres remain speculative assumptions. New data steadily descends. The engine accelerates. Resolving the technical noise, however, only exposes a far deeper historical wound waiting in the planetary past. The foundational paradox of this solar system rests within the life cycle of its central star. This red dwarf belongs to the most common stellar classification, outliving brighter stars by trillions of years. Biology, it seems, has time without limit. Yet, the early formative phase of the star introduces a crushing, irreversible countdown. How much time does fragile life truly need? During its first billion years, a red dwarf radiates a relentless barrage of high-energy ultraviolet light. This violent youth far outlasts our own sun's brief adolescence. For a planet orbiting close enough to sustain liquid water, this timeline becomes a lingering death sentence. Extreme radiation sweeps across the fragile worlds, hunting the lighter gases. Volcanic outgassing must replace this lost atmosphere before the internal planetary resources dry up entirely. You are driving a fragile cargo vehicle through a permanent, howling desert sandstorm. If the storm outlasts your fuel reserves, the wind will eventually strip away every piece of your unshielded payload. The planets faced this exact siege, their primordial water driven into the dark. If a planet cannot establish a stable secondary atmosphere before 5 billion years elapse, it remains permanently barren. This anchors everything and shifts how common life truly is. The very mechanism that makes these long-lived stars exciting is also the most plausible cause of global sterilization. Time is not a gentle savior in this regime. It acts as a patient executioner. No world is guaranteed to endure this violent structural genesis. Enduring the chaotic youth of a red dwarf requires a powerful defense mechanism that never rests. Earth survives solely because a moving core of molten iron generates a profound global magnetic shield. The 7 worlds orbit dangerously close, crushed by gravitational compression. This tidal friction pumps continuous energy into the deep interior, energy the planet cannot survive without. The stretching alone generates heat, 24 times what Earth feels. That churning could sustain a liquid core and a shield. This same tidal engine drives Europa's icy shell into slow, restless motion. The planet endures the same stress, converting gravity into a shield. Now you are standing on a rapidly spinning carousel that continuously warps your physical balance. Your muscles must flex constantly to resist the centrifugal force, generating internal heat through movement. Yet, even an astonishing molten core cannot outmatch the fury of a turbulent red dwarf. The star does not destroy the planetary shield, it overwhelms it. The sheer density of the stellar wind crushes the magnetic bubble so violently that it is pinned flat against the planet's surface. Once the shield is compressed, the atmosphere is left exposed, bleeding out into the vacuum as X-rays systematically rip the molecules apart. A magnetic shield is not a guarantee of survival. In this brutal orbital dance, it is merely a delayed execution. Expanding this planetary reckoning to the grand scale of the Milky Way reframes our place in reality. Red dwarfs make up roughly 3/4 of the galaxy. If the sterilization paradox holds true, billions of rocky worlds across the cosmos are airless tombs. The traditional mathematical calculations for alien biology collapse under the weight of this severe solar reality. The profound isolation of humanity deepens as we analyze the broader interstellar landscape. We look out into a universe filled with planetary cocoons that died before their crusts could solidify. The cosmos trends towards silence, turning populated dreams into dust. The stakes now move from a single solar system to the survival rate of the entire universe. This vast emptiness does not inspire despair. Instead, it evokes an awakening of our cosmic awareness. These failures highlight something exquisite, the precision of our own local architecture. We are forced to recognize the delicate, improbable alignment that shields our home from cosmic erosion. What if our shield had failed instead? The silence of the outer deep beckons us to look closer at the remaining variables. Humanity refuses to accept absolute silence without exhausting every avenue of modern technological exploration. NASA deployed Pandora, a satellite built to watch these violent interactions, launched in January 2026 aboard a SpaceX rocket. This compact mini-fridge-sized telescope will monitor 20 separate star systems over its first year in orbit. This instrument will watch the transits with unprecedented devotion, separating the heartbeat of the star from the world's. We persist because the desire to discover truth represents an essential element of the human journey. The hostile mechanics of the void serve as a quiet, illuminating mirror to our own existence. Somehow, we keep breathing, and each breath radiantly defies the cosmic norm. We stand on a fragile shore where a sun paused its early violence at the perfect moment to shield us. The realization that the universe is largely indifferent makes our awareness of it infinitely more transcendent. We are a brilliant spark traversing an uncrossable ocean of ancient, indifferent forces. As our telescopes probe the light of distant suns, we carry the light of human curiosity forward. we will continue to decipher the code of the stars, standing as the only eyes capable of admiring the majesty of the dark. We look upward, our survival, a fragile spark still burning, radiant and alive.